the second part of Chapter 8, we're going to continue our discussion of rotation, but now look at what the center of gravity is and what that means. Where is the center of something? Usually it's going to be in the center, and how that affects the moment of inertia based on how we're spinning. And then once we can find the moment of inertia is basically a rotational mass, we can use a Newton's second law for rotation. So what is the center of gravity? Well, we looked at these three people on a seesaw, and basically the point where we can balance anything is going to be its center of gravity. So in theory, the center of gravity is right here where the balance point is. Now you can take any irregularly shaped object and try to balance it, and wherever you can balance it, it's the center of gravity. The center of gravity is important because that is where we're going to say the entire mass of the object is. Thus far, we've said the center of a beam is in the center and place its mass there. So when we did a problem with a beam or a ladder, we put the mass of the beam or the ladder in the center. So here's an example of balancing oddly shaped objects. So if we take a racket or a hammer and try to balance it, the center of gravity is going to be in generally the center, which is not necessarily at half the length, depending on if the object is homogeneous or irregularly shaped. The center of gravity is where we model all the weight to be where that force of gravity acts. If we can pick just one point in the entire object where all that weight will be. The center of gravity does not need to be within the object. This is a Fosbury flop and a high jump, and so here's the crossbar. And if you do this just right, you can make your actual mass go under the bar. And so the man who invented this was called Fosbury, and he was able to jump really high compared to everybody else because his center of mass actually didn't jump as high. His center of mass went under the bar instead of over. And so now everybody that does the high jump does the Fosbury flop. So the center of gravity does not need to be within the object. The object can be bent such that the center of gravity goes under the high bar instead. So the center of gravity in this particular position is not actually within the body. But for an object to be stable, the center of gravity must be above the support. So we can shift from one leg to another, and our center of gravity is still within the support. So when you're standing on just one leg, you notice that you lean towards that leg so that your center of gravity is over that support. And here's a couple of pictures of somebody doing handstand. And so this is stable because your center of gravity is over the supports. This is not stable. This person will tend to fall over. So here are three definitions. Generally, we're going to be considered most important the center of gravity because this is the one place where we can place the entire force vector. So if we have a beam, for instance, we want to be able to place this force vector in one spot and call it the weight of the beam and put it in just one spot, and that's generally going to be the center. Now the center of mass is the center of mass, and so this would be the center, the middle area of the mass. And these two numbers are the same if G is relatively constant. So if G is constant. But if you're on something like a small asteroid, or if you're being spaghettified by a black hole, G isn't constant, and these two things would not be the same place. But generally on the planet Earth, the gravity is relatively constant over the length of our objects, so the center of gravity is the same as the center of mass. Now, centroid is more of a mathematical definition. This is the center of area. And generally, it's going to be the same as the center of mass and the center of gravity, as long as our object is homogeneous. Here's a weeble, and weebles wobble, but they don't fall down. And the reason that is because these are not homogeneous. The center of gravity is way down at the bottom because this is really heavy, a heavy material, whereas this is light plastic. And so the center of mass is really, really far down, so it's really hard to knock one of these little weebles over because the center of mass is so low that there's always a restoring torque that the thing just stands back up again. But generally, we're going to deal with homogeneous objects, and if not, we're going to put different homogeneous objects together to make the mathematics pretty simple. but generally we're going to be looking at the center of area to be equal to the center of gravity. So what is the center? Well, it depends on the shape. Common shapes, hopefully you've dealt with most of these before. The circle is pretty simple. The center of a circle is in the center. And for a rectangle, the center is at half the width and half the height. Then for a triangle, triangle is 1/3 off the thicker section. And then there's more complicated formulas for more complicated shapes. We're not even going to get into semicircles. The shapes we're going to deal with are pretty simple, where the most complicated one is generally going to be a triangle. Another important aspect of the center of mass is the line that the object is going to follow. So if you take something like a wrench and you twist it as you throw it, or if you're a gymnast and you have flaming torches and you twist, you rotate them as they throw it, that object will rotate about its center of mass, and that center of mass will follow the projectile motions. So even though the handle itself doesn't follow true projectile motion, the center of mass will. It will follow the classic parabola that we're accustomed to seeing.